Welcome, everybody, to this episode of the Joshua Sutherland podcast. Today's guest is a returning guest, Mats Larsson, whose new book, The Blind Guardians of Ignorance, is due out in a couple of weeks from the recording time. And so it's going to be out on the 8th of December, 2020. And we had Mats in here only a month and a half ago in October 2020. And now we're at the end of November 2020. And the reason we have Mats here is because over that short piece of time, there's been various announcements with regard to sustainability policy, at least in the UK government, with regard to one in the news is a proposed ban on the sale of new petrol and diesel cars in the UK from 2030, which is soon, and sooner than many people were thinking. So we thought it'd be good to get Mats here to comment on that. And if you're watching on the YouTube video, there'll be some presentation slides to help understand what is going on. So Mats, how are you doing?
I'm fine, thank you.
Great. And so what is happening right now with regard to these major announcements with sustainability in the world?
Yes, this is really interesting because I've been looking at these challenges from a system perspective, and I've been arguing since 2009 when I published my book, Global Energy Transformation, that there's a need for a systems approach to this change to sustainability. And now we have a great example here. The UK government has announced a 10-point green plan in the past week, offering 12 billion pounds in investments for green technologies, and this is hopefully going to create 250,000 new jobs in the UK. And but the problem I see is that the plan is not based on a true understanding or vision of what is going to be created and or the new society, the sustainable society that we are all expecting will emerge. The question we need to ask ourselves is how we're going to build sustainable systems to make countries sustainable and resilient. And what I see in this proposal is a lack of a systems perspective, and I'll try to explain, giving a few examples from e-mobility and the ban on petrol and diesel cars, and compare it to the suggestion, also one of the points in the plan of spending a lot of money to promote a hydrogen economy as well. And there are also points in the plan to invest in new nuclear technologies for small scale nuclear plants and new wind farms offshore. So there are a number of components there, but I can't see that they actually harmonize. And the background is that we need to understand the seriousness of the situation and of the need to go fast forward with these changes that are necessary. We can't spend a lot of money into that'll lead us into blind alleys of innovation and development, because one of the biggest challenges that we are likely to face in the next few years is that oil production is likely to go into decline, and that's going to create a situation that few people at present expect. It means that countries will not have enough oil to fuel transportation the way we are used to now, and they will not have enough oil to use as an industrial raw material. And this is a major threat, basically, to our present economy. And we need to understand that at the present rate of production, all conventional oil would be finished in 30 years from now. And the rate of new findings, new discoveries of oil is very slow. Only a few percent of the oil that's produced is identified in new discoveries. So, but the problem is production can't continue at the present pace, and what's expected to happen, based on the analysis of geologists, is that oil production is likely to go into decline already a few years from now.
So on the
climate change.
surface of that, on the surface of that, if oil production decline is a problem, banning the sale of diesel and petrol cars sounds like a good thing.
Absolutely, it's going to move the development forward, and we need this type of some pressure on the development of the new systems. But we also need to focus, and we need to look at the look at this transformation from a systems perspective. So I totally agree with you. It is good that that the government has decided to ban, but they need to understand also what they need to do in order to prepare for a change over to electric mobility, and for cars as well as for heavy transportation. So
Yeah.
the system
So
development needs to start now.
is there a danger that we get busy doing things and we feel good because they sound like they're addressing the problem, but there's no overall plan, and we don't have a lot of time, and we waste a lot of time and resources doing things that ultimately aren't so useful?
Yes, that's the problem with the present approach, and this slightly random selection of new technologies to invest in seems to be mirrored in the new in the 10-point plan as well. And I'd like to illustrate this first by describing the system challenges of electromobility, because this isn't only a matter of getting some more people to buy cars and installing charging infrastructure. It is a major system development that's needed in order to prepare the ground for the rollout of electromobility systems on a large scale. If we look at this perspective of electromobility until 2030 and 2040, when basically most cars in the UK will have to be fueled by electricity, if petrol and diesel cars are banned by 2030, it will mean that there will be a need for 100 terawatt hours of power for the 40 million cars that are at present rolling on British roads. So, and that's equal to 20 nuclear reactors, full-scale nuclear reactors, or more than that actually, or the similar amount in wind and solar. So there's a really, really large need to expand the power production, basically, and in combination with saving power in present applications where that is possible, of course. But it's a really, really large volume of new power that's necessary to make available for transportation. And we need one nuclear reactor. To build it, it costs several billion pounds, and wind power of the same amount is slightly less demanding in investments, but it's still a very large investment. And as power production would increase, the demand for power distribution through the power grids would probably have to double. So the capacity of the grids would have to become twice as high as it is at present. And I rely on some figures that have been calculated for Denmark, and assume or extrapolate that maybe there would be a need for 60 billion pounds in investments for only to get 20 million electric cars in the UK to be powered by electricity. And in addition to this, there's a need for the development of smart grids and implement smart grid technology on a large scale, which isn't available at present. It's virtually a new area of development that needs to be opened up, because all owners of electric vehicles can't charge their vehicles at the same time, even if all electric car owners would plug in their vehicles when they arrive home at 5 o'clock or 6 o'clock in the evening. Charging needs to be managed so that it is spread out over time and optimized so that it's done during the night when there's a smaller demand for electricity for other purposes. So there's a need for smart power grids, and there's also a need for electric road systems, because all cars cannot charge in stationary chargers. There's a need for the opportunity to charge on the go when cars drive, and that can be done through tracks in the roads that need to be installed, basically, in order for these systems to work. But in order to have all cars electric, there would be a need for perhaps 1.5 times the number of cars in terms of charging posts. And many people park the cars at curbs in the cities, and they don't have a parking space where they could have access to a charging post. So there is really likely to be a big need for electric road systems as well.
So just on that previous slide, Mats,
Yes.
the amount of infrastructure needed then is vast. And I was just looking up how many existing nuclear reactors are in the UK, and operational ones is about 15. And there are 2 more under construction and about 6 more which are in the planning stage. So if we've only got 15 currently, and you're talking about 20 new ones being needed, if all of the energy was generated purely by nuclear, it is a huge undertaking. Plus, then there's all this distribution aspect.
Yes, and I assume without having checked it, it's if you look at the volume of wind power that's produced every year, it's probably smaller in the UK compared to the volume of nuclear power. At least in Sweden, the volume produced by nuclear power is twice as high as the volume produced by wind power. So so if we say that we could instead invest a lot in wind power or solar panels, we need to realize that those systems would have to be expanded several times compared to their present size.
Yes,
in order to supply. And with wind power, of course, we have the problem also that wind power is intermittent. You only get wind power when there's wind, and that means that the need for smart grids and the need for storage of electricity increases, so that you need so that if you have a lot of wind at times when there are not so many cars that are connected to the the power grid for charging. You need to store that some of that power in order to use it and at later times during the day, because it's not very likely that countries will be able to build their power systems the way they are built at present, when there is no management, no control of the use or of the availability of electricity, and a lot of power is lost basically during the day when at times when the demand is low.
Yeah. Okay, so I stopped you from moving on to the next slide.
Yes. In addition to the technical development needs, there's a need for new companies and business models, and this is to a large extent in areas where there are no systems and no business at present. So that will have to be developed from scratch and through experimentation. There's a need for companies, for example, that trade effect on grids to make effect available from customers that have a surplus of effect or in their subscriptions, to and sell that to customers that need to buy additional effect. And there's a need for companies that offer charging and build infrastructure, but it's difficult at present, and it will continue to be difficult to run charging infrastructure with a profit, because it takes a long time for the charging of a car, even with a supercharger. It takes quite a long time, and the amount of money that a car owner pays for charging is much lower than what the people pay for filling up their petrol or diesel car with petroleum fuels. So it's the revenue from charging decreases, and the cost of operating charging infrastructure increases compared to the cost of operating a filling station, and it becomes quite it's difficult for utilities companies and other operators of infrastructure to make a profit from it. So this business development is difficult to calculate, and it's difficult to set a time frame for the perspective when there will be profitable business models for this. In reality, this is not very surprising. And if we look at it from a historical perspective, it's nothing new, because government financing has been needed in most technology developments in history. I mean, governments financed the construction of railways and the building of phone networks and power grids in various ways. And the US government financed the development of space technologies and IT and internet technologies. So it's nothing new, but in those days, governments did not expect quick payback on their investment, and there is an expectation at present which is unrealistic and unfounded. I believe that these systems will be that companies can build up these systems and rapidly make a profit from them. It is a fact that in the early stages of technology development and in the implementation of new systems, there are too few customers to finance the very large investments that are necessary to build up the systems. And that's what we find now, that the people who are the few people who buy electric cars and use electric cars, they can't finance the build-up that will be needed over the next few decades. So, but it's also pointless to deny the complexity and magnitude of this challenge and of this transformation, because the global pace of change if you measure it, at present is 500 years for electric cars. There are 1.2 billion cars in global vehicle fleets, and there are about 7 million cars, electric and hybrid, across the world, which makes up about 0.5% of global fleets, and it would take at this pace 500 years with an additional 2 million cars every year at present, that are added to fleets. And there's no competitive system for heavy transportation. It's meaningless to measure or even to mention the pace for that. And to just put this figure in perspective, 2.5 million cars every year is the number of cars that are bought in the UK every year. And that's the number of electric and hybrid cars that are sold all over the world in a year at present. So there's a very big need to expand the production of electric cars, and there's a need to dismantle basically the production of petrol and diesel cars over a period of only 10 years, and also to redeploy the resources that are at present engaged in car production and maintenance of petrol and diesel cars. So, and the several points in the program do not seem to harmonize. There is investment planned for wind and for small-scale nuclear energy projects, but this focus on electric cars is with this focus on electric cars, there's a need to very rapidly expand power production, both probably from wind and from nuclear power plants. And it's probably not enough to focus on small-scale nuclear projects, because there will be a big need to expand power production on a large scale. So that doesn't seem to harmonize. And if we look at another aspect of the plan, of the investments in hydrogen development, they don't seem to make any sense at all from this perspective. Hydrogen is a visionary new technology, and hydrogen is a medium for storing electricity. But hydrogen needs to be produced from, for example, oil. And oil is at present the primary feedstock for hydrogen production. But there are also very large drawbacks of hydrogen. It's energy inefficient, and it demands extreme amounts of power compared to battery electric applications. So to illustrate this, if the British car fleet would be driven using hydrogen, it wouldn't need 20 nuclear reactors. It would need twice as many, 40 or even more than that, probably. So only for the car fleet, and the same number of electricity would be needed in order to fuel heavy transportation with trucks and buses. So that's a really that's a system solution that doesn't seem to harmonize. A hydrogen economy is in some ways similar to the development of e-mobility. But the situation for hydrogen is that it's at an earlier stage of development compared to e-mobility. So in order for hydrogen to arrive at a similar point of development as e-mobility is now, it will take perhaps a few decades. So there will be very large development needs over decades until the present situation that we are experiencing now with electric cars can be arrived at for hydrogen. And with hydrogen, there's no infrastructure in place. As we know, we have all countries have power grids, we have large-scale power production, and we can use all these installations and resources in order to build on, to expand very rapidly power production and distribution, and we have complete workforce that's very well versed in hydrogen technology and hydrogen. No, sorry, we have a workforce that's very well versed in electric technology and electricity in various ways, and in the business of utilities companies. But in the area of hydrogen, we have very little of any infrastructure or very small production resources compared to the ones that will be needed if we apply hydrogen on a large scale in society.
And we can't simply take the petroleum industry and have them do this hydrogen work. I mean, petroleum handling is significantly different.
Yes, I mean, with petroleum, we of course have refineries, but they are adapted to refining oil and to refine oil into its different fractions like petrol, diesel, and the other fractions like heavier fractions that are used for
Aviation fuel.
yes, and asphalt production. Bitumen is a byproduct or one of the products of bitumen that's used for the production of asphalt or for road coverage. So, but those plants and those resources cannot be used for the production of hydrogen. We need to build entirely new production plants for and many new production plants for hydrogen. And some experts say that hydrogen is so energy intensive. As I said, it requires twice as much energy to produce the hydrogen to drive a car 10 kilometers as it requires in terms of electricity to charge a battery for the same to get the car to drive the same distance. So there's very little in terms of resources in the petroleum industry that can be used in the hydrogen industry. There's a need to dismantle resources and there's a need to, if hydrogen will be used on a large scale, we need to build very large new resources in a number of areas, not least in order to distribute hydrogen and produce it on a large scale, and also, of course, to develop the business models and the companies that can do this, and to teach the general public to use hydrogen and persuade them to want to use hydrogen instead of electricity, or as it is now, petrol and diesel. I've said some of this already, but for e-mobility, the building blocks are in place. We have power production, we have electricity grids, we have a basis for battery electric cars that cost anywhere from £20,000 up to much more, £100,000. we have, although the cars are not produced in the volumes that the petrol and diesel cars are currently produced, we have the organizational structures, which is also very important, of utilities companies, national grid operators. We have regulatory bodies for um, um, electricity, the electricity sector, and we have competent workforces at all levels. So we can expand this e-mobility based on resources that we already have, but there's a significant need we need to keep in mind to build smart grids, business, and develop business models and companies in some areas, expand charging infrastructure, and also to build the competence of workforces in the new areas that need to be added. So there is a very large need to for new investment in e-mobility as well. But the pace of transformation in this sector is at present 500 years for cars. Heavy transportation has not started. Smart grids development has not started, and all of these things will require significant resources and will take a significant time. And there's a need for business development and rollout that's not been started either. And there's a need also to speed up development and to invest more in the penetration of electric cars and less expensive, in the development of less expensive car models and family cars and so on that are not at present available on the market. But for hydrogen is 2 or 3 decades behind battery electric, or if we look at it from the perspective of transformation, perhaps 1,000 years, because there is no change going on, and there are only a few thousand hydrogen cars on global roads, and there is no large-scale production of hydrogen, no distribution infrastructure, and cars at a very early stage of development, they're not likely to catch up in terms of price or facilities to catch up with battery electric cars, because battery electric cars are developed very rapidly at present and are pulling away from hydrogen fueled cars. And there's virtually no competent workforce available in most areas, because hydrogen is at present used in industrial applications and for industrial purposes, but not at all used as a fuel or as a for the purposes that it is intended in the future if we start a large-scale hydrogen economy. So the hydrogen cars at present cost more than £50,000, and there's a need to build systems from scratch, and the energy efficiency of hydrogen cars is unlikely to ever catch up with battery electric systems. So and the need for new power production in case the entire fleet of cars or would be made up of hydrogen cars, it would be 80 nuclear power plants instead of 40 for a car and heavy transportation, if battery electric were to be used. So hydrogen has significant drawbacks compared to electricity, and it's important, if hydrogen is going to be used on a large scale in any country, it's important to pinpoint the areas where hydrogen could become competitive. Like in Sweden, for example, we have a railway that's running inland in the north of Sweden, where it will be too expensive to electrify the tracks. So in that, for that railway, there is the idea that it could be run on electricity, because then it would probably become a competitive solution there to use hydrogen to power the railway, and it would be easier to transport hydrogen to the trains there, compared to building the electricity grid necessary to electrify that railway. So in the area of hydrogen, it's at present not meaningful to calculate the pace of development, and it will take 1 or 2 decades at least until large-scale implementation of hydrogen systems could be started. And in order to start this, we need to consider, or governments and companies that are going to be involved in this need to consider what the components will be of fully functioning systems. It's not only a matter of hydrogen cars and some hydrogen fueling stations. It's a much more complex system that needs to be built up than that. So my conclusion here, or the basis of my argument, is that in all these situations, we need a system perspective on the development. We need to understand the challenges and the time frame, and we need to understand the challenge of the peak in oil production and the potential that the oil production may decrease in the years to come, compared to the challenge of climate change and emissions of carbon dioxide, and the need to reduce carbon dioxide emissions, because the solutions that we need and the investment and the time frame for activities will have to be adjusted to the severity and the time frame of the challenge that we need, that we try to mitigate. And we need to determine which systems that will be necessary and the components that need to be developed for these systems. So if we want to use hydrogen systems, we need to define the areas where they will be most competitive, or where they are likely to be most competitive, and define the areas where traditional power systems and battery electric systems will be more competitive. And that can be done at present. It's not something that will change over time, because we can see the status of development, and we can calculate and determine the end with quite significant certainty, the end result of in terms of cost and time and so on, for the different systems, what they can deliver and what needs to be built up. So we need to assess what research and development is needed for the different systems, and determine the time frame and investment needs. We need to analyze the time frame and investment needs for infrastructure construction, and we need to calculate the penetration speed of the market, and how we can get users, customers, consumers to use the new technologies, and abandon the use of present technologies, and calculate the time frame and investment needs for that. And I find that very little of this system related analysis has been going on as when the 10-point plan has been developed. When these calculations have been made, there's a need to select the most promising system for each application, and we need to look at what system do we need for car transportation, heavy transportation, railways, etc., and what additional components do we need to build. And in the aspect of car transportation, it seems that battery electric system will remain more competitive on all aspects, as far as I understand it. And then there's a need for a very thorough and detailed analysis in order to find out if hydrogen transportation systems or hydrogen storage of energy is likely to become more competitive in any area, except in, for example, in the case of remote railways or other situations where it will be difficult or uneconomical to run them on electricity and through the power grid. So this is a very brief and quite superficial analysis of these two systems, and an attempt to compare them from a competitiveness perspective on a number of different aspects. But and this type of analysis, of course, needs to be done in much more detail in order to determine the viability and to guide decisions in terms of which investments need to be made in development and implementation and so on.
Yes, what you described, Mats, makes a lot of sense, especially from a systems engineering background, that the plan or the future we're trying to create can only be done where all of the pieces of the puzzle link together well. And right now, as you said, in the way at least this 10-point plan has been presented, these different items aren't interacting with each other for a bigger goal. And what I was thinking, I'll bring up on my screen the 10-point plan just to give the viewers a sort of sense of this. So this is from a EDI, a website based on sustainable business, who have taken the from the government website, this kind of text document, and turned it into a illustration. And so these 10 points, which we've touched upon, I guess, Mats, would you be able to, for each of these points, I know that we've said that the big problem is that they're not holistically linked together to a wider goal, but would you be able to just go through each of them and give a very quick summary of sort of good, bad, or maybe?
Yes, yes, I can. Offshore wind is an area that needs to be expanded rapidly because of the need to increase power production. Hydrogen is an area that I think needs to be there needs to be a question mark on hydrogen because of the well, seemingly low competitiveness and the aspect that battery electric systems can be used instead of hydrogen, and hydrogen seems to be less competitive compared to battery electric solutions. Nuclear is probably a technology that countries need to invest in, even though I know in many countries there's a lot of resistance to nuclear, but the alternative to nuclear would be a much more dramatic increase in wind and solar production, and perhaps sea power generated from the sea. But those technologies are not anywhere near maturity. It's so I think that it will be difficult to avoid nuclear as part of the solution. Electric vehicles is clearly a necessary and very competitive alternative to petrol and diesel cars, and it seems that the electric vehicles will also be the preferable and most competitive solution for heavy long distance transportation if we get or if we invest in electric road systems. Public transport and the incentive to use more bicycles and walk and use other environmentally friendly forms of transport will be necessary. Aviation and shipping also need to be become more efficient, and that there is a need to develop new environmentally friendly technologies in these areas. And there's also we already see some electric ships, and there's talk of the imminent launch of light airplanes and small airplanes fueled by electricity. Public sector as well, to improve energy efficiency and so on in various areas. That will be necessary in order to free up more electricity that can be used for the transportation sector. And that takes time, because it takes time to work with each building and each factory and each installation to find the opportunities to make them more energy efficient and to implement the technologies that are possible to use in order to save reduce the energy consumption. Carbon capture is a question mark again, because carbon capture doesn't contribute to the transformation of transport systems or the transformation of other areas in society. It's with declining oil production, we will have access to less oil, and we will be able to emit less carbon dioxide anyway. So I'm not sure whether carbon capture will be relevant over the next few years as an investment alternative. I believe that carbon emissions will decline, and they will decline once oil production is reduced. And
so on carbon capture, one place I've heard is steel production and concrete production produce a lot of CO2.
yes,
And so there's and presumably we will always want concrete. And so the idea that those industries to be net zero, maybe they will require capture just because that's inherent in their process.
yes, that is possible, absolutely. But the investments need to be weighed against the need to expand electric mobility systems. So the investments that will be necessary in e-mobility will be very large, and in order to speed up the growth of e-mobility, it is possible that we will need to focus less on investments in other areas. So I'm not saying that it will not be possible, and it will not be that it would not be desirable, but it is possible that when we have to prioritize, that we need to prioritize investment in other areas. And even if steel companies and concrete companies in principle may not be the ones that invest in e-mobility, there is still a need for the financial resources in the other areas. And from a society perspective, it makes we need to look at which areas have the most pressing needs for investment, and try to funnel as much investment as possible to those areas.
Absolutely, that makes sense.
I mean, based on the information that we have at present, we don't know for sure, but I want to make the argument and to initiate that type of discussion that it may be necessary to weigh different investments against one another. Nature, of course, that's a good purpose. And in the case of making London the world's capital for green finance, is also a very commendable ambition, of course, and one that I see as very important in the light of Brexit and those developments.
Great. Well, thanks for going through all that, Mats. That's very useful for people to get a sense of not just the problem of not having an integrated plan, but what each of those points are. So the book is out 8th of December. Did I get that right?
Correct, yes.
Which is a Tuesday, and you're holding a live book launch in the virtual world
Yes.
to avoid the COVID challenge. So I encourage everyone listening to attend that, where you can ask Mats questions about the book. And then once it's out, go and get it and read more. And so you can understand about the blind guardians of ignorance. What's the full title, Mats?
The Blind Guardians of Ignorance, COVID-19, Sustainability, and Our Vulnerable Future. A handbook for change leaders, young and old.
So if you want to be a person who can affect this and maybe build that integrated plan and not be a blind guardian, but be a guardian who has their eyes open, I think this would be a great book. So Mats, thanks for coming back again, and best of luck with the book launch.
Thank you very much, Joshua.